cycloaddition reactions in chemistry, especially in synthetic chemistry. Cycloadditions in organic synthesis. Cycloaddition reactions describe the union of two independent pi bond systems through a process that is involving a cyclic movement of electrons and resulting in the formation of a new ring. So what is a cycloaddition? Addition, the term itself indicates the union of the two independent pi systems. Here, what are pi systems here? A double bonded molecules, or the molecules with multiple bonds like double bond and triple bond. Especially cycloaddition reaction involves two pi systems, that is two alkene systems, through a concerted process, nothing but the cyclic movement of the electrons in the pi systems to form a ring system, a new ring system. This type of the addition reactions are highly helpful to obtain different cyclic carbocyclic systems in synthetic chemistry. These are considered most powerful bond forming reactions. These are most powerful bond forming reactions because these reactions have the ability to form many bonds in one step, and they have potential to generate several stereogenic centers. So predictable stereochemical outcomes may be possible with the execution of cycloaddition reactions. A cycloaddition reaction is categorized as M plus N cycloaddition when a system of M conjugated atoms combines with a system of N conjugated atoms. So here is a diene involved, it may be conjugated, that may combines with a system of conjugated atoms. So this type of the combination will always gives us a cyclo product. So that is why the name given cycloaddition. Addition that might give the cyclo compound. In this case, we always obtain carbocyclic compounds. Carbocyclic compounds are the one in which the cyclic structure is made up of carbons only. Let us see the categories of cycloadditions. The categories of the cycloadditions include, there are three most important types of cycloaddition reactions. One is a Diels-Alder reaction, also known as 4+2 cycloaddition. Diels-Alder reaction or 4+2 cycloaddition. Due to this Diels-Alder reaction, we can get 6-membered carbocyclic rings. So they form, the Diels-Alder reaction will form 6-membered carbocyclic rings. Next one is 1,3 dipolar cycloaddition. 1,3 dipole cycloaddition, also known as 3+2 cycloaddition, which results 5-membered heterocyclic rings. In the previous case, what is the product? That is a carbocyclic ring. Carbocyclic, you will be noticing here, the entire cyclic or ring structure has carbons. Here all the 6 atoms in the ring are carbons. Whereas 1,3 dipole cycloaddition or 3+ cycloaddition, 3+2 cycloaddition, which gives 5-membered heterocyclic ring. So this cyclic ring consists of 5 atoms. So among the 5, at least one of the atom may be different. So here heterocyclic, hetero means different. So the carbocyclic ring may contain one or more atoms other than carbon. So the atoms other than carbon includes nitrogen, oxygen, sulfur, etc. When all the ring atoms are carbons, the cyclic structure made up of carbon atoms only is called a carbocyclic ring, whereas the ring structure which has been formed with the inclusion of other than carbon atom are the carbocyclic ring, which may contain at least one heteroatom such as oxygen, nitrogen, sulfur. So 3+2 cycloaddition is an important reaction that will give a heterocyclic ring structure. Many of the drugs used by people today are heterocyclic in nature. And the next one is 2+2 cycloaddition. As a result of 2+2 cycloaddition, we will obtain 4-member carbocyclic rings. The first one is diels-aldol reaction. The product is a 6-membered carbocyclic ring. 2+2 addition. 4-membered carbocyclic rings are formed, whereas 3+2 cycloaddition gives the heterocyclic ring. So these are the types of cycloaddition reactions. Let us go one by one. Diels-aldol reaction. So it was the prototype of cycloaddition reactions. Very famous reaction it is. It is also known as a 4+2 cycloaddition. So here is a diene. Diene meaning two double bonds are there. Di means two, and ene means double bond. So here are the two double bonds. This is a conjugated diene. Conjugated means double bonds are arranged in an alternative manner. So here we see single bond, double bond, single bond, double bond, single bond. So that this is an alternative arrangement of single and double bonds. Such type of the diene is called a conjugated diene. And the next reactant is called dienophile, which is a dienophile, which is also another alkene. A substituted alkene is called dienophile. So when the dienophile and the diene combined in the presence of heat, so what is happening here? A carbocyclic, a ring structure is formed, a new ring structure is formed. It forms here carbocyclic ring with generation of 4 stereogenic centers here. If you notice, the stereogenic center means the carbon. It has been attached to 4 different kinds of the atoms or groups. Here carbon is there at the point given by asterisk, star mark. Here is the carbon. Here is a CH group, or CH double bond CH. Here is one alkyl substituent. Here is another alkyl substituent, and one hydrogen must be there here. So that this is a stereogenic center. This one is also a different stereogenic. So therefore 4 stereogenic centers can be generated in the reaction. So it is called 1,3-diene, the first carbon, and the third carbon, 1,3-diene. So this one is a dienophile. Here 6 pi electrons were involved. So that is why here are here is 4 pi electrons and here is 2 pi electrons. So that here, and each double bond represents 2 pi electrons. So that is why here 6 electron system is there. This one is diene has 4 pi electrons. Dienophile has 2 pi electrons. So that 6 pi electrons are involved. So that is why the name of the reaction is also known as 4+2 cycloaddition. And the substituted alkene is dienophile here. Here the substituted cycloalkene. Now this product is called cycloalkene. has been substituted with different alkyl groups. Maybe R1 and here also R1 positions are substituted with same alkyl groups. Diels-Alder reaction is thermally allowed, which is usually exothermic in the forward direction, as it is forming new pi bonds at the expense of the two pi bonds. So why it is exothermic? Here, here 3 pi bonds were involved. Here loss of 2 pi bonds occur. Since here 3 double bonds were involved. At the end product, we have only pi bond. The rest of the 2 pi bonds were expensed, were lost in the process. So thereby it is an exothermic reaction. The loss of energy may be sometimes happen by liberation of heat. Always remember the sigma bonds are stronger enough than pi bonds. Diels-Alder reaction is often referred to as the most powerful reaction of organic chemistry when compared to all other reactions. A 6-membered cyclohexene ring is generated from the acyclic precursors. So this is acyclic, having no ring structure. This is also acyclic, but the product is cyclic one. So that a 6-membered cyclohexene ring is generated. Cyclohexene, hexa means 6, a 6-membered ring, which is a cyclic one. This cyclic one is obtained from acyclic precursors. Precursors means starting materials. Up to a maximum of 4 continuous chiral centers can be generated. That means stereospecificity is established. Since the product has 4 stereogenic centers, it has got the credit of giving continuous chiral centers. So these being accomplished in a single step. So there was no further steps involved. Only single step to obtain a cyclic ring. Okay, this is a very important characteristic of Diels-Alder reaction. Although Diels-Alder reaction combines a diene and a dienophile to generate a cyclohexene, the reaction between simple 1,3-butadiene and the ethene is very slow in practice. But Diels-Alder reaction can made facile by employing dienes with electron donating substituents. So this is our diene. So our original diene and a dienophile won't react rapidly. They react very slowly. They'll react very slowly. But what is important here, we can obtain a facile reaction, fascinating reaction, by selecting a dienophile with an electron donating group. Whereas the dienophile has got electron withdrawing group. In doing so, the reaction we can make the reaction facile and fast. Yeah. So what electron donating groups substituted into the diene? Methoxy group is a very good electron donating group. Similarly, aldehyde group. Aldehyde is an electron withdrawing group that makes the reaction possible. When electron poor diene is utilized in the Diels-Alder reaction, the preference for the diene is reversed with electron rich dienophiles. Vinyl ethers act as dienophiles. So such type of reaction is called inverse electron demand Diels-Alder reaction. So electronic substituent effect on the diol-Saldar reaction is very promising. Electron rich dienes react with an electron poor dienophile. In a typical diol-Saldar reaction, dienophiles that are most reactive towards simple dienes are those with the electron withdrawing groups. So electron withdrawing groups must be there. Conjugated diene must be there. Among the most reactive dienophiles are benzoquinone is a dienophile, malic anhydride, benzene, and fumarate esters, fumaric acid. These are the best dienophiles. So what we are discussing, the best dienophiles are the dienophiles that are most reactive towards simple dienes with electron withdrawing groups. Most reactive dienophiles are, this one is benzoquinone, malic anhydride, benzene having triple bond, dicyanoacetylene, malic anhydride, fumarate anhydride, fumarate esters. Alkenes conjugated to the functional groups such as sulfones, alkenes conjugated to the functional groups act as effective dienophiles. So our dienophile is an alkene. When alkene is substituted with the sulfone group, aldehyde group, ketone, ester, nitrile, nitroso, then it becomes reactive dienophile. So that is why alpha beta unsaturated aldehyde, ketone, esters, nitroalkanes, nitriles are the best dienophiles. In the case of diol-Saldar reaction, so far we have seen the properties, the characteristics of the dienophile. Dienophile is an alkene substituted with some of the groups such as aldehydes, esters, anhydrides, nitroalkanes, whereas the dienes are substituted with the electron donating functional groups. So the dienes substituted with electron donating functional groups serves as effective dienes. Those functional groups are alkyl groups are best electron releasing groups, ethers, amines, sulfides, trimethylsilyl ethers. So electron releasing groups, always remember alkyl groups, alkoxy groups like methoxy, trimethylsilyl ether, thiomethyl group. These are the best electron releasing groups. When these electron releasing groups substituted with dienes are substituted with these electron releasing groups, they serve as effective dienes in the diol-Saldar reaction. So that is regarding cycloaddition reactions. Okay. So sometimes it may be asked in the examinations what are cycloaddition reactions and explain about diol-Saldar reactions. Let us see some of the questions relevant to our topic. When we see model question papers, I'm presenting a model question paper, previous end examination paper. Check whether or not the question is there. Explain 1,2 addition and 1,4 addition reactions of conjugated dienes. 1,2 addition and 1,4 addition reactions of conjugated dienes. This will be our coming sessions. This will be the topic of our coming sessions. See here, 6 5 or 30. So each question carries 5 marks. In that, explain the following reactions: Cannizzaro reaction, Diels-Alder reaction. Okay. So sometimes it may be asked in your examination, like 5 marks, 6 marks. So here 6 questions are given. Each question carries 5 marks. In that, at least 2.5 marks will be allocated for Diels-Alder reaction. And more or less 5 marks question will come in the examination regarding Diels-Alder reaction. So let us see a few more papers, whether the question is there. SN1, SN2, E1 and E2. Markovnikov's rule and peroxide effect, 4 marks. We can write this question, write a note on Markovnikov's rule and peroxide effect. So both are exactly opposite. Alloprophilic addition of conjugated dienes. So alloprophilic addition of alkenes we are studying. Polarity of molecules, intermolecular forces. Acid base on the basis of Lewis theories. Write a note on Diels-Alder reaction. So write a note on Diels-Alder reaction. About 6 marks it was asked in the previous paper. In the coming days, let us see what is the addition reactions of conjugated dienes. So far we have seen addition of alkenes, addition reactions of alkenes. But what is also important, addition of conjugated dienes also important. I hope, I thought it is important because it appears many times in the previous papers. And also Diels-Alder reaction. Regarding the cycloaddition reactions, it is better to write as low as possible for that question. So we'll have to limit the question for 5 marks or 6 marks. Diazotization and coupling reactions, amide, conversion of acid to amide. Conjugated diene, explain the addition reactions of conjugated dienes. Addition of carbene. Dehydrohalogenation of alkyl halides. E1, E2 reactions. Markovnikov rule and peroxide effect with an example. Breuer-Stein theory. Protic and aprotic solvents. Write the electrophilic addition reactions of alkenes. 10 marks question, direct question. E2 versus E1. Isomerism with suitable example. Markovnikov's rule with example. One two addition versus 1,4 addition. Let us see in the case of conjugated dienes in the next class. Explain the reaction mechanism, kinetic, stereochemistry, and factors influencing SN1 reaction. Please go through the previous questions. If you're able to answer these questions, definitely you'll get good marks in the organic chemistry examination. Markovnikov's rule and peroxide effect. E1 and E2 reactions, SN1 and SN2 reactions, Bayer strain theory. Okay, our mid examinations questions are like that only. I'll prepare the questions from this previous questions paper only. Please go through the question papers. Write a note on dienes and its types. So we are talking about alkenes only. We are not entering into the topic called dienes. At the time of discussion of dienes, let us see 1,2 addition and 1,4 addition of the dienes. Okay. That's it for today class. We have learned about what are cycloaddition reactions, how many types of cycloaddition reactions are there. We have seen to some extent Diels-Alder reaction. Okay. In that we have seen diene characteristics as well as dienophile characteristics. How to make the reaction facile. Dienes with electron releasing groups will be best for Diels-Alder reaction. Dienophile with the electron donating species serve as best or effective dienophile.